All right, hello everybody, and welcome back to this game. What is this game? It's been forever and a day since we played this game. So what are we doing here? Well, you can probably see CPU craft, and I'm also assuming that you could see from the title of the video. What we're going to be doing here, this is a project that we're going to start. We're going to build a computer in Minecraft. Oh yeah. So yeah, we're going to build a computer in Minecraft. This is going to be a computer based off of like real world principles, how actual computers work. We're going to have registers, we're going to have a bus, we're going to have memory, we're going to do all that fun stuff. It is not, however, going to be a computer anything. It's not going to be a computer on the same magnitude of anything modern today. We're going to have 3 registers, and most computers have like 8 plus nowadays. If you don't know what a register is, don't worry, we'll explain it. This is intended to be an educational series as well. So we're not just going to build it. I'm going to be explaining the process. I'm going to be explaining how things work, what exactly a register is, how it's made of flip-flops, how a bus works, how we can make a central processing unit that's going to be able to handle all of the different instructions. We're going to cover how to do binary arithmetic. We're going to be doing some logic gates in this. We're going to be doing a lot of logic gates. If you find that I don't explain them well enough here, I actually have an older video, like from, I think it's the second video I ever put on my YouTube channel. The video quality is absolutely horrible, but like the way I explained it is still pretty decent. I just checked. A couple of rules. We're not going to be using command blocks at all. This is going to be pure redstone. Yeah, we're going to be using pure redstone. We'll be using pistons. We'll be using whatever we can get our hands on. I'd like to avoid using like that little trick where you can like do the stair-steppy thing with slabs and get redstone going up. You can get redstone going up. Oh, wow, I did that all kinds of wrong. Anyways, you can... How does one do this? There we go. This should work. Ta-da. Okay. You can do redstone weirdness like this, and it will actually connect. How about I actually trigger the right line? Yeah, it'll connect, weirdly enough. Yeah. So I'd like to try to avoid that because that just seems really hackish and stuff. But we'll do what we gotta do. Although there won't potentially be a whole bunch of up-down in this series. Also, we are using, if you look up in the upper left, you'll see, first of all, an awesome number of frames per second. I should VSync this. Second of all, you'll see it says 1.10 redstone fix. So Panda4994 is his name on YouTube, released a fix for redstone essentially, and I'm gonna explain a little bit what this is. So you'll notice here I have a diamond of redstone, and it's actually this is a texture pack by Mary the Lapis Demon, I think. I think that was her name. I'll link to it in the description. Yell at me if I forget to. And it's a nice little texture pack. They're 3D. The redstone's 3D. It'll go up the edges and stuff. It shows you the power levels on the thing. So we can see this is 0 right now. If we power this, you can see 15, 14, 13, 12, etc. It'll get all the way around. So we're using this texture pack just to see things better a little bit. We're going to be using the redstone fix mod. Now I'm going to explain what this is. I said we're going to use no command blocks, and yet you see command blocks here. This is a testing thing. So you can see when we trigger this line of redstone, you probably heard it. That redstone block goes off. So what this is this is designed to test. It's got a couple of different commands. Essentially what it does is it makes a redstone block right here, and then it immediately replaces it with a stone block in the same tick. So this blinks every tick, and if we pop it on, you can see this thing's just going to go nuts. Yeah, once a tick. Little crazy. So what I did was I put a little minecart going around here. It was just going in a circle. and I made a bunch of these. I made 64 of them, and I just turned them on. Boop, boop, boop. And I figured out roughly how many I could get before the minecart started lagging around its track, which is a cause of a symptom of tick lag. And so I did that with just normal vanilla Minecraft. And then I turned them all off, and I installed this mod, and I turned them on one at a time to see how many I could get running without the tick lag. So, and I put the diagnostics here. So before the redstone fix, I could get roughly 6 going. 5, the minecart was pretty consistent. On the 6th one, it started to jitter a little bit. After this fix, I turned on all 64 of them, and I still couldn't see the minecart jitter. And to the best of my knowledge, there was no significant tick lag after running 64 of these things all the time, which is pretty impressive. I think that's a testament to how efficient this mod makes it. You can also probably notice that we've got the music on in the background. I like the music a little bit. I have it down low. It's not going to be intrusive. If you end up not liking it, let me know. So this was a test that I did just to see exactly how efficient this mod is, and it's pretty efficient. So here's what we're going to do today. We're going to sort of discuss exactly the overview of this series. We're gonna draw out a really simple architecture for our CPU. So we're gonna have up at the top here, we're gonna use signs. We're gonna have our input, and this is essentially what we're gonna do here. Is this is essentially just gonna be a big read-only memory that we can modify. So the computer won't be able to change what's in the memory. It'll only be able to read out what we have manually put in there. So it's really going to probably end up looking like a giant grid. Whoops. A giant grid of redstone, something like this. And then we'll have torches. I don't have redstone torches on my hotbar. I don't need command blocks. Yeah. So we can decide. Oops. That didn't quite work. Let's get that over. That's not the right click button. So we can decide which lines of these are powered when we turn this off by I'm gonna turn that down a little bit, by where we put the torches, right? So we can configure what each line does. And so if we have a bunch of different lines here, let's see, I need one more on this side. If we have a bunch of different lines here and we have them all set up differently, let's see, for this one we want those two activated. So if we want this memory position, and we'll talk a little bit more about what that means later. If we want this position, we can see that this position has a 1, a 0, a 1. Okay? Whereas this position has a 1, 1, and a 0, and we can access them like that. So this is a read-only memory because there's no way that the computer is going to be able to change it. I mean, there's ways you can do crazy stuff with pistons and whatnot, but but we can modify it just by changing where we put the torches. And various other things like that. We might come up with a little bit more modular of a system, but this is what I've got for now. So I've customized this map with some game rules just so that we don't get things dropping all the time. It's always daytime. Tile drops, game rule tile drops is set to false, etc. So anyway, we're going to have that input, and that's kind of what that's going to look like. We're going to talk about let's see. What's the best way to introduce this? Let's see. I'm just gonna add some empty spots here. Actual. Okay, that should be right. So we've got input, counter, instructions, control, accumulator, LUB. Okay. So next we're going to have things that are called registers, and we're going to put these here. So this is going to be our A register. Now what registers do is they're basically just temporary holding places for information. So when our computer is going to do something to a piece of information that it pulls from our input memory here, let's put this sign up on top, then to do anything to it, it's going to have to put it down into one of these registers. And we're going to have three. We're going to have an A register, we're going to have a B register, and we're going to have a C register. Not a register. Okay, and this one is really not creative. Let's go grab this. The C register, what its job is, it's going to be hardwired to produce an output on a couple of redstone lamps here. So we're going to literally hardwire this thing in. So whenever we decide to put something in this C register, what's going to happen is it's going to light up these lamps right here. And they won't end up being right here. This is just a mock-up demonstration. It's going to light up the lamp so we can see exactly what the computer did and what we wanted it to output. The A and B registers will just be temporary storing places for all the information. Now in between them, we're going to have what's called an arithmetic logic unit. Also known as an ALU. And what this does is this actually can do math. Now our computer is going to be able to add and subtract. So essentially what's going to happen is we're going to have, we're going to load something into our A register, and we're going to load something into our B register, and then we're going to tell this thing to add these two and put them in our A register. And we'll explain how we tell our computer to do things, and we'll explain like what the point of that is later. So it will be able to add and subtract, and this is the bit that's going to do this. Okay. We're going to, this is, okay, so now this part is all kind of all stuck together. We're going to have our control unit here. This is what is frequently called like the CPU, the central processing unit. This is what makes all the decisions. So what's going to end up happening is we're going to give our computer commands that look like LDA, add, sub, right? And it'll even be able to do like LDA 1011, which is the address that we want it to load stuff from. So these are little commands like this. Now eventually these will all be translated into binary, is how computers work. And we'll talk about exactly what the commands are and everything once we start getting into actually building the control unit. But suffice to say, for now, computers do things all in numbers. So what this does is this is going to take the numbers we give it. We'll give it like a 10110101 type of thing. This is going to take the numbers, it's going to figure out what it means, and then it's going to actually do what it means. So maybe 1011 means add two numbers together somehow. And so it's going to say, oh, it's telling me 1011. I'm going to do some stuff over here and add a number, and I'm going to put it here. And that's what the command will mean. And like I said, we'll talk more about the commands and how we're going to program them into our control unit later on in the series. When we actually start building this control unit, then we'll start talking about the commands that this thing can do. Yeah, we're gonna have a little thing here called the instruction register. Register, not register. And this is a normal register just like the other two. The only difference is we can't use it to store data. The controller, the control unit is going to basically monopolize this. And this is going to be hardwired right here. In fact, actually, that's a good idea. I like that. This right here is going to be hardwired. Let's grab a repeater real quick. We're going to start getting detailed and crazy with our mock-up diagram here. So this bit is going to be hardwired right into the output. Okay, and actually these registers are hardwired right into our ALU as well. This instruction register is going to be hardwired into the control unit. So this instruction register, all it's going to do is it's a storage place for the instruction that this thing is going to do. This thing won't actually store it itself. It'll just read from here. so that it knows what it needs to do. So if we give it the 10110101, that's actually the 10110101 is actually going to be stored in here, and then the CPU or the control unit is going to read it from the instruction register and then send signals to everything else. Now the crazy way that this thing's going to send signals is what's called a bus. Okay, and we're going to have a bus here. We're actually going to have two buses in our computer here. And there's going to be one over here. Yep. Okay. So we're going to have two buses. Buses essentially are just ways of making sure that data gets places. We're going to talk about that one over there later. We're going to talk about this one now. This one is going to be our control bus. So what's going to happen is when this thing is going to tell things to do things, it's going to send out signals on this control bus to specific places. Now, everything is going to be wired into this control bus. Even this, I really didn't do this as great as I could have. Yeah. In fact, let's see if we can't get a command block to shift this down a little bit. Let's turn on our F3 mode. You're going to be an impulse, needs redstone. We're going to do clone from x plus 1, standard y, and standard z to, let's see how we got 8 here, so 9. Okay, so x plus 9, whoops, standard y or self y, and z plus 1. And we're just going to copy that down to x1, normal y, z1. We're going to set, what is it? Replace, move. Let's see if I did that right. Yeah. Oh, I missed the redstone. Oh, well. That did it. Okay. Here we go. Okay, good. There we go. Now this is a little bit better. So this control bus is going to be hardwired into everything. Yeah, everything. Except for our input here. Our input is the only thing that's going to be free from its tyranny. So eventually this thing's going to say, hey, I want you to move something from A into B. And we'll see why that's important later. So it's going to send a signal out here to A and tell A to open up. Or it's going to tell A to send its information. It's going to tell B to pick up information. And information is going to be transmitted on this bus. It's called a data bus or our address bus. We're going to call it a data bus. Bus does not have two S's. And not everything's going to be hooked into this, but a lot of things are. The CPU actually isn't. The instruction register, our input is going to be hooked into it. We'll talk about a little bit about what these are later, but these are indeed hooked into the data bus. So this bus is where all the data is going to flow out. So all the stuff in register A is going to come out here, flow down, and then into register B. This control bus, the only thing that signals can come out of on the control bus is the control unit. Every other unit is only going to receive signals. Yeah. And again, how the control unit knows which signals to send to where is going to be controlled by the instruction that we give it, which is stored in this instruction register. Now, in order to access our memory, actually, I lied. Our input is not hooked up. I'm a horrible person. In order to access our input, we're going to have what's called a memory address register. Oh, wait, no, it is. It's totally hooked up to the data bus. I apologize. I suck. This is called a memory address register. What this does is this is going to store a location. So this is we're going to tell it, hey, we want the data in position 1101. And so it's going to store 1101. It's going to pass it here to our input. And it's going to get that information and tell the input to shoot it out onto this data bus. Right? actually, I'm oversimplifying this a little bit. So in that case, this is going to be controlled by our control unit because it has to know when to shoot its information out onto the data bus. So that's what the memory address register does, is it tells us where in the input we want to be looking. Now here's the funny thing about computers is the program and the data are all just numbers and they're all stored in the same place. So we're actually going to write our program out, right? And then in line with our program, we'll be having all the data that we want too. So we'll be running, this is a weird, each of the sandstone blocks was supposed to represent a bit. I guess I should be using redstone or something. So maybe this is like one command here or whatever, and this is another command that's telling it to do something. Oh my gosh. I should use a different block, how about? Oh. We'll use a redstone lamp. Okay. So this is going to be one bit of data. This is going to be one of our instructions that we're going to tell our register. It's going to tell our control unit what to do. This is going to be another instruction. This is going to be a number, a bit of data that we want. And this is going to be another instruction type of thing. Like, we could do that. So this line here is an instruction. This line here is an instruction. This line here is data, though. It's a number. And then this line here is another instruction. So it's weird how things work like that. Because as far as the computer's concerned, it's just a number. It could execute this data that you give it, which is not good, because if you didn't plan it to do that, it's going to do something that you didn't plan. Or maybe it doesn't know what to do. It has no idea what 10101011 means. Maybe it just doesn't know. Who knows? And then it'll explode effectively, and we'll see some pretty crazy errors and bugs. Yeah. So we have to have a way for the computer to know where it is here, which one's it working on. And that's going to be solved by our program counter. And as this starts at 0, when we start up the computer, it's going to start at 0, and it's just gonna go. It'll start at 0, and then it's going to tell this memory address register, hey, I want whatever's at 0. Input's going to take 0, whatever's at 0, and it's going to put it here in this instruction register. Then the control unit's going to do whatever 0 says, whatever command we told it to do at the very top. It's going to do it, and then it's going to tell this program counter to go up by 1. And then once that goes up by 1, then it'll tell the memory address register, hey, I want the thing in position 1. So then the input's going to say, all right, here's the thing in position 1. It's going to go to the instruction register. And it's going to be a big cycle like that. And this is actually how computers work. They use numbers as instructions to tell it what to do. And they also use numbers as data. Now, our computer is going to have 16 bytes of memory, 16 bytes of RAM. Modern computers usually have at least 8 gigabytes of RAM. That's a gigabyte is roughly a billion bytes, roughly. It's not quite. My computer here has 32 gigabytes. I give Minecraft 8 of it. So Minecraft has 8 billion bytes to do whatever it wants with. Our computer is going to have 16 bytes. Not enough to do much at all. And we have to fit all of our program and all of our data and everything for that in the 16 bytes, which is possible. And I'm going to show you how. So we've got this little overview of what our computer is going to look like. We've got some mock-up connections here. It's not super detailed yet, but it's going to get the job done for kind of a conceptual explanation. What we're going to do as we go forward is essentially we're going to pick one of these parts and we're going to work on it. I think what we're going to do first is we're going to work on the registers. And in fact, the A register and the B register and the C register, we can all knock out at once because they're all pretty much exactly the same. The only thing is when we finally build the computer, we're going to have to hardwire this C register into some output lamps, but that's not really hard to do. So that's probably what we'll end up doing next time. I hope that you enjoy this series. I hope that I can explain everything well. I should say real quick, I'm not an expert on this. This is a hobby of mine. I have built a computer like this before. I've done it before. It's been a little while, but I still understand the concepts. I still understand things. So I hope we're gonna have a good time. I hope I don't blunder too badly. I hope you guys learned something from this about how your computer that's running Minecraft or running YouTube is actually doing what it's doing. Like I said, it's going to be a way bigger scale than what we build here, but we're going to build it. And also, this will just be a fun thing to actually build a computer in Minecraft and to show all of you how it's done. So we're going to stop there. I hope you enjoyed the video, and I will see you all next time. Farewell, everybody.